In this clip, I will show you how to configure authentication for OSPF. Unlike EIGRP and RIP, we will configure the authentication key right in the interface configuration mode. However, to enable authentication for OSPF, we can do that in the interface configuration mode like we have for the entire OSPF area when we configure the OSPF process. To speed up this demo, I've already removed the RIP configuration and configured a basic OSPF configuration. On router 1, I've already configured OSPF 100 and set passive interfaces as a default, but enabled Gigabit Ethernet 01 and then added the networks. Additionally, to enable OSPF version 2, I entered the command IP OSPF 100 area 0 on interface Gigabit 01. Router 2 has a similar configuration. I configured the respective networks and enabled OSPF on the Gigabit 01 and 02 interfaces. The same goes for router 3. I configured the appropriate networks and enabled OSPF on Gigabit 01. I will first show you how to configure authentication but not use a hash. Then we'll take a look at a packet capture and see exactly why that is not a good idea. After that, we will fix our configuration and then use a hash. And then finally, we will configure the other two routers to use authentication. Again, I'm starting out at router 1. To configure authentication key, we can jump right into the interface configuration mode and define an OSPF authentication key by entering the command IP OSPF authentication-key, followed by the key of global 123 with a capital G. And to actually enable this key in OSPF, I'll enter the command IP OSPF authentication. Alright, so OSPF authentication is enabled, but it is sending the key in plain text rather than a hash. To see what I mean, let's take a look at a packet capture I have between R1 and R2. Here is the OSPF hello packet, and then if we expand to OSPF, and then the OSPF heading section, and then the OSPF header section, we can see that the auth type is a simple password, and the password itself is right there in plain text. So to fix that, let's jump back over to R1 and remove those two commands by entering no in front of them. I'll hit the up arrow, and then hit Ctrl A to place the cursor at the beginning of the command, and then type in no. I'll do the same thing for the other command. To actually enable the hashed authentication, enter the command IP OSPF authentication. And then if I hit question mark, we can see that this command is complete if we didn't want to use hashing. But since we do, I'll enter the keyword of message-digest. Once we enter that command, we can see that the router is letting us know that there isn't a valid authentication key configured. To enter a hashed key, we can use the command IP OSPF message-digest-key, followed by a key ID, and I'm going to use 1, followed by the keyword MD5, and finally, the actual key that we want to use, which again is global 123. And it looks like the neighbor on router 2 finally went down since we enabled authentication. But let's jump back into the packet capture. This time, when we look at the OSPF header of a packet after authentication was configured, the authentication key is not in plain sight. Rather, the authentication type is cryptographic. This PCAP file will be available in the exercise files of this course. So, let's configure router 2 for authentication. This time, we will enable authentication on the entire OSPF area 0 by going into OSPF configuration mode, and then enabling authentication by entering the command area 0 authentication, and then if we enter a question mark, we can see that if we enter the command as is, it won't be using a message digest. So, let's specify that message digest keyword so the authentication key isn't in plain sight. The nice thing about specifying that the OSPF will be using authentication globally in OSPF configuration mode is that if the key is not configured on each interface, that interface will not establish an OSPF neighborship. This is a way you can use as a security measure to help ensure any new interfaces that will be participating in OSPF will have to have a key configured in order for it to work properly. I know mistakes can happen when at the command line, and sometimes commands are forgotten to be added. This way, you can try to eliminate as much user error as possible. Alright, now let's configure the authentication key we want to use. Again, I will configure both interface Gigabit Ethernet 01 and 02 at the same time using the interface range command. To specify the key that will be hashed, enter the command IP OSPF message-digest-key, followed by sequence number 1, the keyword of MD5, and finally the key of global 123 with a capital G. If we jump over to router 3, we can configure this quickly. Let's switch back to configuring both commands on the interface Gigabit 01. And again, the commands are IP OSPF authentication message-digest and IP OSPF message-digest-key, followed by the sequence number of 1, the keyword of MD5, and the key itself of global 123. If we wait a few seconds for the routes to propagate and then enter the command show IP route, we can see the two routes to routers 1 and 2 learned via OSPF, which as a refresher is designated by the O. Lastly, if I ping 1.1.1.1, source from 3.3.3.3, that should work, and it does. Alright, in the next clip, I will teach you how to secure BGP.